Hi students, this is a lecture for week 1 of Python. Today is January 9th, and I'm going to go over some of the things that are happening in the first 5 lessons of the Python course. So, first of all, some of you may be wondering, why are we using Python? Why are we using some other language? The reason is this: Python was developed by I'm trying to think of the guy's name off the top of my head. I can't think what it is, but econometricians at some business. Anyway, purposely designed to do things fast from a data analysis perspective. Now, is Python the best coding language? It's very popular. Is Python the best coding language out there? I don't think so. Is it the best statistical analysis software out there? I positively think that that's not the case. However, it is open source, which means it is free to load up and doesn't put any more burden of cost on students. And I looked through a lot of job openings in data science, data analysis, business analysis, things like that. And I would say probably close to 70% of them are asking for programming such as R or Python or equivalent. So as a data scientist working for big companies, I never used Python. Quite often, I have to say always, had access to some statistical analysis software that was licensed, whether it was SAS or JMP or SPSS or Minitab or MATLAB, or even Excel has some pretty good analytical tools. So I never really had a need to, become a good Python programmer. Having Python skills would be good for you, and I also think that it's a great thing to be able to put on your resume, because it's one of those triggers that says, hey, we're going to look at this guy versus we're not going to look at this guy. So this is why we're teaching in this course, in this data science curriculum. Thing about open source tools is a couple things about them that I don't particularly like. Number one is, since it's open source, anybody can write any sort of functionality they want, and you might have 35 different ways to do something. So if you want to create some sort of particular analysis with some particular graphs associated with it, there might be a whole bunch of different ways to do it. You might not ever figure out all the ways to do it, and new ways could pop up any day. It would be a lot of work to try and figure out which one was best. You might find one that works sufficiently for you and stop there, and that's fine. That's what a lot of people end up doing. But having said that, the documentation sometimes is not great. Sometimes it's really good. Other times it's not great. Sometimes there's a tool that does what you want it to do, but it's for a very specific type of data, and maybe your data varies from the specificity of that data just a slight bit, and it makes it so that you can't do what you want to do. Anyway, so open source tools have a lot of good sides and a lot of bad sides. When it's documented well, it's done very well. And there's a lot of people out there that are using Python that are willing to help you. Stack Overflow is a great place to go and ask questions. Of course, if you go to Stack Overflow to ask questions, first 50 responses are going to be, I'm not doing your homework for you. And then maybe you might get somebody coming along that's actually willing to help you a little bit. So anyway, just a couple of the pluses and minuses of open source stuff. And again, the main reason we use it is because this is what employers are looking for. Okay, having said that, so what are we going to go over in the first few lessons? Python has some idiosyncrasies. For example, I think it's Python, but maybe it's R, I can't remember. One of them is very, very sensitive about uppercase letters versus lowercase letters. So if something's supposed to be lowercase and you did it uppercase, it's not going to function correctly. And I think that might be R, but maybe it's Python. Maybe it's both of them. I don't know. Another thing about Python is indenting is very, very important, because rather than having, when you're doing loops, rather than having begin and end statements to know when the loop ends, or brackets or something like that, which a lot of programs use for that sort of thing, it's all dependent on how far your line's indented. If it's indented the same, it gets inside the same loop. If it's not, it's a signal to the program the loop is ended. this may be something that's super comfortable for you, but on the other hand, it might not. For example, when I was first learning to program, 30 some odd years ago, a lot of instructors would say, hey, white space is really important. Make sure you have a lot of white space, and make sure you use tabs and things like that to keep track of where you're at. So we did it as a convenience for somebody who's going to be reading the program later on. We didn't do it as a functional integral part of the program. But with Python, you have to. So, there's just some things like that, idiosyncrasies that you have to be aware of and you have to pay attention to. Okay. Having said that, what are some of the things we're going to talk about in the first week of Python? Of course, very first thing is you need to learn how to load Python onto your PC, and there's some pretty good step-by-step instructions on how to do that in the first lesson. Then, and I'm just going to give a brief overview without going into any detail at all, the functions, the abilities that will be discussed will be things like operations. These are mostly going to be mathematical operations. Then we're going to go into discussion about lists and tuples and loops. That will be followed by creating dictionaries, which is where you're defining variables and adding to the programmability of what you're doing. And then finally, to end off the week, we're going to go into a lesson about functions, which are collections of commands that can be, some programming scenarios call these things scripts or queries, things like that. Anyway, in Python, they're called functions. You put together a group of commands, you give it a function name, and then you can just call that function. It'll do a whole list of commands rather than a single line item command. Anyway, just some basic functionality that's going to be gone over this week. As I said before, I am not a great programmer. I can do it okay. I haven't used it a lot in my work, mostly heavily involved on the statistical analysis side of the house. So my ability to help you get out of tough spots is a little bit limited. Angelina, on the other hand, she's a good programmer, and she's come up to speed on the Python and the R stuff, and so she's very capable of helping you get out of the sticky spots you're in. Also, I would highly, highly recommend that if you're having troubles with anything you're working on and just not able to figure out how to get through something, if you go to the Slack channel, the Data Science Slack channel, and post your questions there, we seem like we constantly have 2 or 3 really, really good programmers in the data science program, and they quite often are willing to jump in and help out. Quite often it's because they're struggling with something they're working on, and somebody comes up with a programming question. All of a sudden they feel like, oh, I can be useful here, I can contribute here, so they'll jump in and help out with that, rather than aggravate over something that's driving them crazy with the statistical part of the program. So, having said that, work hard, ask lots of questions, let myself, Angelina, and the group know when there are things you're challenged with, having struggles with, and help get through that. One thing I did want to mention, this is true for both Python and R. And this might be a source of frustration to a lot of you as we go on through the program. But once we give you the foundation, fundamental basics of R and Python, you're going to find a lot of time you're working on an exercise, and the instructions will be something like, okay, now you need to go and run an analysis of variance. I'm going to let you explore how to do that, rather than give you statement by statement, line by line instructions on how to do an analysis of variance. And you might get to that and you might think, man, this curriculum just is not helpful at all. Well, okay, there's a couple reasons I've done that. Reason number one is, like I talked about before, quite often there's a lot of different ways to do something. So I don't want to bias you towards a way that I think is best doing, or even just a way that I know of doing it. I might not know the right way or the best way, or what is most useful to you. So I want you to explore that. Number two is, as you get into your job as a data scientist or a data analyst or a business analyst, I promise you there are not a bunch of cookbooks sitting around for you to just read down line by line, do this, do this, do this, do this, do this. People will bring problems to your desk all the time, and they'll tell you a little bit about it, and then they'll leave. And you're kind of on your own to figure out how to solve the problem. It might be something you've done before a dozen times, and it's not hard for you to get in there and chip away at it. Or it might be something that you either haven't done for a long time, or maybe possibly have never done, maybe don't even know that much about it. The job does require quite a bit of poking around and exploration on the web. There are tons and tons of resources on the web to do probably pretty much anything you'd want to do from a data analytics perspective. Rather than cram the curriculum filled with those resources or even links, because always new stuff is coming up all the time, it would become obsolete very quickly. You just the opportunity to poke around on the web and find out what you can learn about what you're doing is a great skill to have going forward. So I want to try and develop some of those skills now. I get it. Some of you are going to think I'm just being lazy. I'm not. I want to give you the tools you need to help you succeed. Quite frankly, giving you cookbooks is not the tool you need. So anyway, plug away at it, ask lots of questions, poke around on the web, look for ideas. If you have ways the curriculum can be improved that you think some critical elements are missing from it, let me know about that too. Be happy to try and do what I can to make that better. We're in a continuous improvement loop with the curriculum now. So, okay, have a great week. We'll talk to you later. Thanks. Bye.